Hello students, welcome to Sreenath. So in this video we are going to discuss the 7th chapter, which is fractions from 6th class max students. From 6th class CBSE max subject, we are going to discuss the 7th chapter students. Okay. So before we are going to start this session, just we will see what are the concepts we are going to learn. After that we will discuss each in detail. So by the way, my name is Karthik Nune. We are creating videos on all chapters on all subjects from class 6 to class 12. So please do subscribe our channel, also like and share our videos, students. So without wasting time, we are going to start this session. So we'll start the concepts. How are you, students? So here first we will going to see the introduction to this fractions chapter, why we need fractions. Later topic is what is meant by fraction. Okay students, after that we are going to know fractions on the number line. So how to represent the fractions on the number line. So after that, what is meant by a proper fraction, what is meant by improper and mixed fractions, and what is the thing about equivalent fractions, and there are some example students we are going to solve, and simplest form of a fraction, how to derive the simplest form of a fraction. So next thing is that students, that is like fractions. So like fractions and unlike fractions, and comparing fractions, how to compare the fractions, and comparing like fractions, comparing unlike fractions. So all these concepts we are going to learn, students. So in the middle there are some example problems you are going to do, students, but we will don't deal about the exercise problem, students. Those will be explained by some other students. So those will be uploaded in future, students. So if you want really the exercise problems to be uploaded by us, so please let us know, students. And addition and subtraction of fractions, how to add or subtract like fractions, and how to do the task with unlike fractions, also adding and subtracting unlike fractions, and how to add and subtract mixed fractions. So these are the examples and exercise problems. So this is the end of the chapter, students. So this is the thing we are going to learn. So this whole chapter we are going to learn, students. So hope you have know what are the concepts we are going to learn. So we will start our discussion, students. Okay. So Subhash had learnt about fractions in class 4th and class 5th, students. So whenever possible they use the fractions, students. So on one occasion what happened, Subhash forgot his lunch, and so his friend Farida has brought his lunch, and they have shared their lunch. So she had taken 5 puris in her lunch box. So she gives 2 puris to the Subhash and then half puri to the Subhash. So finally, how many puris Subhash have? 2.5 puris. And how many puris that Farida have? She is also having 2.5 puris, students. So here there is occasion we can use, or we can express this in the form of fraction, students. Okay. So next thing is there is another situation. So here there is this is the whole, and we have make it into 2 parts. Okay, students. So suppose if puri is in this shape, so what they have done, they have cut the puri into 2 parts. Suppose if they have made that puri into 4 equal parts, so 4 equal parts, then 1/2 represents is 1/2, and 4 equal parts is represented by 1/4. So students, what does the 1/4 means, and what does the 1/2 means? So here, students, so out of there is single puri, one puri, it has made into 4 equal parts. So out of the 4 equal parts, one part is shaded. So what is the amount, or how the shaded part is represented? How? That is, it is the one part of the whole. So there are basically 4 parts and they have taken only one part, 1 out of 4 parts, students. Okay, next thing here is if you just take half puri, in that half puri you have make it into 2 pieces, or otherwise half puri is made into 2 pieces. So if you take this half as the whole, or otherwise if you shaded 2 parts, then it is 2 by 4 and it again comes to 1 by 2, students, like that. So students, can you understand 1 by 2 means? Suppose if it is the whole thing and if you divide it into 2 parts, whole is divided into 1 part is divided into 2 parts and one half is one part is shaded. So what does this represent? This represents the 1 by 2 part of the whole. So if there is a puri and we have cut it into 4 equal parts and you have shaded the one such part, so that part is represented as the 1 by 4th, which means it is the one part out of 4 parts. It is the one part out of 4 parts. It is the one part out of 2 parts. Similarly, if you see here, there is a circle. There is a circle. How many parts it has make? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, students, 8 parts. So these are 8 parts. So out of 8 parts, we have taken only one part. So what is its portion? That is 1 by 8. So the whole is making into 8 parts, that is represented in the denominator. And how many parts we have shaded? That is one part we have shaded. That's why it is 1 by 8, students. Next here, this is, there are almost 7 parts and out of 7 parts, 3 parts are shaded. So we called it as 3 by 7. Out of the whole, we have made them into 7 parts and 3 of them are shaded, students. Okay, so finally what we can conclude, the students, a fraction is a number representing part of a whole. Students, it is the important thing. A fraction is a number representing part of a whole. The whole may be a single object or a group of objects. The parts have to be equal. Okay, students, that is the case. So whole, part of a whole, so it is one part of the whole. There are the 3 parts of the whole. That is the thing, students. The parts have to be, so, and whatever the parts you are making, they must be equal. Okay, students, so now we discussed about fraction, a fraction. So we have already discussed previously about the fraction, students. So a fraction is means a part of a group or of a region. So what is the definition of fraction? Fraction means nothing but a fraction means a part of a group or of a region. So previously also we have discussed that part of a whole. So fraction means a part of a group or part of a whole group or whole region, whatever it may be, whatever we are taking, in that how many, and each part must be same, students. So here there is an example for part. So what is the example here? If you see, students, here 5 by 12. So it is a fraction, which means what, students? 5 by 2 is a fraction, which means what? 5 parts out of 12. Here is 12 is the whole. The whole is make into 12 parts. Suppose if there is a circle, if you make them into 12 pieces, 1 2 3 1 2 3 4 5 6 7 8 pieces. If you make one further more 4 more pieces, so if you make 12 pieces, 3 parts, 3 parts, 3 parts, so total 12 parts. So we have taken this whole circle, it is a whole thing, and we have made it into 12 parts, and we have shaded 5 parts. Suppose if we shaded this and this, so what is the shaded region? That shaded region represents 5 by 12. So 5 parts are shaded out of 12 parts. It is a fraction, students. Already also we called it as the 5/12. 5/12. Okay, students. So what does the 12 stands for? So 12 stands for the whole. We have breaked the whole into parts. How many parts? 12 parts. And what does 5 stands for? So that 5 stands for, we have taken out 5 parts only. So and that 5 is called as what, students? It is called as the numerator, and the 12 is called as denominator. 5/12. 5 is numerator, 12 is denominator. Okay, students, that is the king. So what is meant by the numerator and what is meant by the denominator? If you want that simply, so if there is a fraction like that, 2 by 7, so the number which is on the top of this bar is called as the numerator, and the number which is below this line is called as the denominator. So in the 2 by 7, what is the numerator? 2 is the numerator. So if I given you 4 by 15, I asked you for denominator. What is the denominator of 4 by 15? 15 is the denominator and 4 is the numerator, students. So finally, I think you have understood what is meant by a fraction. Fraction consists of a numerator and a denominator, and fraction represents a part of a whole group or whole region, students. Okay, so and each part must be equal. That is the condition. Here is the game. You can, if you wish, you can play it, students. So there are example problems you can solve, students. Next thing is fraction on the number line. So fraction on the number line. Okay, students, so we know number line and we have represented the integers, whole numbers, natural numbers on the what, students? On the number line. Now if we want to represent the fraction on the number line, how we will represent it? So students, we know if it is a number line, if it is the 0, and if it is the 1, and if it is the 2, and if it is the 3, it goes like that. So we know where to locate the 0 on the number line, where to locate the 1, 2, 3 or any 4, 5 or 10, 11, anything on the number line. So how to represent the natural numbers, how to represent the whole numbers on the number line, we know all that stuff. So here if you mark the fraction, how you will represent it? Suppose if you want to mark the 1 by 2, how you will represent it on the number line? So does the 1 by 2 is greater than 0 or not, students? Yes, it is obviously greater than 0. Does the 1 by 2 is greater than 1, students? So then the answer is no, students. It is not 1, not greater than 1. So it is less than 1 and it is greater than, it is less than 1 and it is greater than 0, students. So it must be lie between the 0 and 1 in the number line. So if you observe in the number line, 0 is here and 1 is here. So the 1 by 2 must be in between the 0 and 1. So it is at any place, 1 by 2 is any place between the 0 and 1, students. Okay, that is the case. So students, since we have to show 1 by 2, we divide the gap between 0 and 1 into 2 equal parts, and since we have to show 1 by 2, we divide the gap between 0 and 1 into 2 equal parts and show one part as 1 by 2. So 1 by 2 means what, students? If you take 1 by 2 means what? Means one part, it means one part out of two parts. So the whole is made into two parts. Suppose if it is the whole, this whole thing is made into two parts and the parts are equal, and out of the two parts we have taken one part. So this means this shaded region is the 1 by 2. Out of the two parts it is one part. So here that means 1 by 2 fraction, students. So here also the space between 0 and 1 is have to be broken into two parts. The whole space between the 0 and 1 is made into two parts, and it is saying that 1 by 2. So that's why that half of the space, which means one part of it is marked as 1 by 2, students. That is the thing. So that 1 by 2 is in the middle of the 0 and 1, students, half part. So if we take the space from 0 to 1 as the whole, and if you make it as in the two equal parts, and one part shows the 1 by 2. That is the thing, students. Suppose now we have to represent 1 by 3 on the number line. How you will represent? 1 by 3 means what? So the whole thing is made into three parts, and we have to select one out of it, and whole made into three parts, and have to select one part. Okay, students, that is the thing. That is 1 by 3. We are taking only one part out of the three parts. Okay, students. So again, does the 1 by 3 is like it is greater than 0 and less than 1. So again, if you take the number line 0, 1, 2 like that, 1 by 3 means the space between 0 and 1 is making into three equal parts. Okay, this is one part, this is another part, this part, and out of these three parts we are taking only one part. So one part represents 1 by 3. Okay, students, which means here it is 1 by 3. So this represents two parts. Suppose if you want to represent 2 by 3, two parts of the whole parts. So starting from 0 to this point, that is 2 by 3. So 1 by 3 means 1 out of 3 parts. 2 by 3 means 2 out of 3 parts. Next there is 3 by 3. It means taking 3 parts out of 2 parts, which means taking the whole. So taking the whole means taking the 1. 3 by 3 gives rise to 1. That's why it is 1, students. This is the case. So, and what about the 0 by 3? 0 by 3 is nothing but it is the point 0, students. We are taking nothing. So we are taking nothing of the space. The space between 0 and 1 is making into 3 parts, and we are not taking any part. Then it represents 0 by 3. The space between 3 by 3 means the space between 0 and 1 is making into 3 parts, and we are taking whole parts, 3 parts. So it is 1. That is the case, students. Similarly, if you want to show the 3 by 7 on the number line, this also represents the same. Suppose if you want to represent 3 by 7, which means smart, take 3 parts out of 7 parts. Again same, the space between 0. Okay, students, this is the 0 and this is the 1. Okay, students, the space between 0 and 1 is making into 7 equal parts. 1, 2, 3, 4, 5, 6, 7 equal parts. So first part is 1 by 7, second part is 2 by 7, third part is 3 by 7, fourth part is 4 by 7, fifth part is 5 by 7, sixth part is 6 by 7, seventh part is 7 by 7. It is the 0 by 7, like that. So we have to make the space between 0 and 1 into how many parts? 7 equal parts. Like that, students. Like that we have to represent the So can you able to understand how to represent the fractions on number line? Okay students, in this way how to represent. Next thing is about proper fractions. What are proper fractions? What are proper fractions? So we have what is the fraction and how to represent it in a number line. Then wow, and here there are some fractions, write them on the number line. So what you have to observe is that, so what are the fractions, or does any fractions which are lie beyond the 1, which lie beyond the line? If you see students, all these fractions lie beyond the below 1 student. Suppose if it is 0 and if it is the 1, it is the number line. If you want to represent this 3 by 4, which means you have to 3 by 4 means you have to break the space between this and into 4 parts, and it is almost taking 3 parts, so it is at here this point. Okay students, like means here 3 by 4. Next thing is 1 by 2, which means we have to 1 by 2, we have to make the whole space between 0 and 1 into 2 parts, and you have to take 1 part, which means at this point 1 by 2. And 9 by 10, which means you have to make these holes into how much parts? 10 parts, and you have to write here mark 9 parts, so it is 9 by 10. Next thing is 0 by 8, you have to make the space between them into 3 parts, and you have to take nothing, which means it is here. And next thing is 5 by 8, which means 5 by 8, which means you have to break the space between 0 and 1 into 8 parts, so 8 parts you have to make students. So 1 2 3 and 4, 1 2 3 and 4, 1 2 3 4, 1 2 3 4, like that students. So out of the 8 parts you have to take 5 parts, so it is around here 5 by 8. So if you clearly observe, we have represented all the fractions on the number line, and all the fractions are lie between the 0 and 1. Any of the fractions does not go beyond the 1. So beyond the 1 there is 2. So is there any fractions which are lying between 1 and 2? No, not at all. So all the fractions which lie left to the 1 are called as the proper fractions, students. Okay, we call those the proper fractions. So if as a proper fraction is a number representing part of a whole, students. Okay, what we are having in a proper fraction? So proper fraction is a number, it is a number representing part of a whole. So every time if you take the whole thing and if you make it into some equal parts, it will always represent some part out of the whole. It will represent some parts out of the whole, students. Okay, that is the case. And one more thing, in a proper fraction, students, that numerator is less than denominator. So if you observe all the examples here numerator is 3, denominator is 4, so 4 is bigger than 3. Here numerator is 1, denominator is 2, 2 is greater than 1, and 9 by 10, 10 is greater, 0 by 3, 3 is greater, 5 by 8, 8 is greater. So in a proper fraction, if you want to just know whether it is a proper fraction, just thing is that denominator is greater than the numerator, students. Okay. Next thing is improper and mixed fractions. What about this is thing about proper fractions, and what about improper fractions? Improper fractions and mixed fractions. So here there are friends, students. So they are sharing their tiffin. So along with their food, they had also brought 5 apples. They are having 5 apples. But how many of there? There are only 4 friends. They are having 5 apples. So after eating the other food, the four friends wanted to eat apples. So after eating it, they want to eat the apples, friends. So how do they share their apples? Okay, students. So 5 apples and 4 friends. How to share? If you are in that situation, how you will share 5 apples to all those 4 friends? So suddenly Anagna has said that, so first everyone take 1 apple, later 1 apple left, and that apple is making to 4 equal parts, and each we can take quarter of the 5th apple. So will you agree it? Yes, it is a good good sharing. So how many apples will everyone get? So everyone will get 1 apple at the first. Later students, so everybody get 1 apple, and later there is 1 apple, it is make into 4 parts. So quarter of the apple, student. Okay, so that's why. So everyone will get 1/4 apple, quarter of the apple, so that they will get 1 apple and 1/4 of the 5th apple, 1 full apple and 1/4 of the a quarter of the 5th apple, like that. So Reshma said that is fine. So Reshma said, okay, it is good, but we can also divide each of 5 apples into 4 equal parts and take 1/4 from each apple. So what they have discussed is that, students, so another thing is that, students, we can also divide each of the 5 apples into 4 equal parts. So there are 5 apples, no, so every apple is making into 4 equal parts. If you see here, everybody is getting 1 full apple and 1/4 of the apple. So in this case, 5 apples are making into, each apple is making into 5. If you take 1 apple, it is making into 4 pieces. Okay, students, it is making into 4 pieces, those 4 pieces, like that. And every apple is making into 4 pieces. And after that each are taking 5 quarters, like that. So in both the ways the sharing is same, students. So what they have done basically, so they have break the apples into 5 apples, 5 apples into each apple into 4 pieces, each apple into 4 pieces or 4 quarters. So like that 5 apples are making, and how many are getting? Each one is getting 5/4 of apples. Okay, students, 5/4, each one is getting 5 pieces, each one is getting 5 pieces out of 4 apples. There are 4 apples, out of the 4 apples they are taking the 5 pieces. So students, the fractions where the numerator is bigger than the denominator called improper fractions. Here you can see the improper fractions. Proper fraction, in improper fraction, numerator is greater than denominator. In improper fraction, numerator is greater than denominator. Okay, students, so this is the thing. So when in the previously proper fraction, numerator is less than denominator. In the improper fraction, numerator is greater than denominator. That is the case. So 3/2, whether it is a proper fraction or improper fraction, students. Obviously 3 by 2 is a improper fraction. 12 by 7, what does it sense? It is also improper fraction. Why? Numerator is greater than the denominator. And 18 by 5, it is also improper fraction. So like that, students. So Ravi reminded John, what is the other way of writing the share? Does it follow from Anagna's way of dividing 5 apples? So John nodded, yes, it indeed follows the Anagna's way. So what we can do is, everyone is taking one apple and one part of the apple. So that's why it is like one full apple and 1/4 of the apple. So we can write that 1 and 1/4 as 1/4. Okay, students, 1/4. One apple and 1/4 of the apple. And it is also is same as 5/4. Is same as 5/4. Okay, taking one is sharing the apples in this way and another is sharing apples in this way. Both ways is same. So that's why 1/4 is equals to 5/4. So here 1/4, it is called as the mixed fraction, students. Mixed fraction. So if you recall the puris eaten by Farida, so what they have done, this is the one whole puri, and this is also one whole puri. It is made into two parts, so it is one whole puri and it is whole puri. So two puris and there is one half, so which means 2 and half. 1, 2 and half, 2 and half puri, students. Okay, and we can also write thus 2 and half is same as 5/2. 5/2, students. There are almost 5 parts like that. So these are called as the mixed fraction, students. A mixed fraction has a combination of a whole and a part. So what is the definition of mixed fraction, students? Mixed fraction. Mixed fraction has a combination of a whole and a part. So here there are examples, students. We are going to solve about those. Express the following as mixed fractions. How to express them, students? How to express them? So first example is example 1. 17/4, students. 17/4. So how to express them as mixed fractions? For that we have to do the division, students. So that is 4 is divided by 17. Then how many times it will? 4 4s are 16. If you subtract, you will get remainder 1. So which means what? 4 whole and 1/4. So here there is a 4. That's why 4 whole and 1/4, students. So it is nothing but 4 1/4. So that 17/4 is 4 1/4. It is the improper fraction and it is the mixed fraction. Similarly, if you do the task for 11/3 also, 11/3 means is same as what? Again you have to divide. How many times? 3 3s are 9. You will get 2. So it is like 3 3/2. Sorry, 3 2/3. This by this, students. Like that. Like that you have to do, students. Coefficient, remainder by divisor, students. Okay, coefficient. First thing is coefficient. What is the coefficient here? It is the quotient and the remainder, students. 3 2/3. 3 2/3. So express the following mixed fractions as improper fractions. So how to represent? These are given mixed fractions and we have to convert them into improper fractions. That is 2 2/3. How you will do it? 2 by 3 means what? That is 2. So it is not 2 by 3. It is 3 by 4. 3 by 4 means it is 2 parts plus 3 by 4 of the first part, students. So which means nothing but 2 into 4 by 4 plus 3 by 4. Okay, students. So it will give rise to 11 by 4. That is the thing. So here how we are doing is, here it is this formula is important thing. You have to remember to convert them. Here it is this formula which is important thing. So next thing is equivalent fractions. What are equivalent fractions, students? Equivalent fractions. So look at these fractions, students. So it is the one part, it is a whole, it is made into 2 parts and one part is shaded. So we first thing is 1 by 2, and if you take this, it is the 1, it is made into 4 parts and 2 of it are taken, so it is 2 parts out of 4 parts. Take this, it is made into 9 parts and sorry, 6 parts. Out of 6 parts, 3 parts are taken, so it is 3 by 6. So these are regarding the part, students. So just now, students, forgot about the parts. Just see the 3 boxes. So by seeing the 3 boxes, so don't bother about these parallel and perpendicular lines inside boxes. Just look at the outside lines. That is, it is the box and it is the box and it is 3 boxes. So just don't bother about the middle lines which are like that, which are like that, which are like that. So just remove them from your mind. Remove these lines. Remove these lines and just see what is the shaded region. So if you see up to here is shaded, this shaded region. If you see here also up to this part is shaded. If you see here also this part is shaded. So if you see, does the 3 looks the same or not? The shaded region on the 3 is same or not? Obviously it is same, students. So in the 3 things, the shaded region is same. So but this shaded region is represented by this, and this shaded region is represented by this, and this shaded region is represented by this. So we say that these 3 are equal. What does it say, students? These 3 are equal. That is the thing, students. So these are called as equal fractions, students. If you know the divisions, if you do the division also, students, if you divide it, you will get 1 by 2 here. Here also you will get 1 by 2 here. So the basic thing is same. So these fractions are called as equivalent fractions, students. Like that. Think of 3 more fractions. So understanding equivalent fractions. So if you see, students, 1 by 2 is same as 2 by 4 is same, 3 by 6. Can you extend this? So 4 by 8 fraction is also looks like same. Next 5 by 10 is also same. Like that it goes on extending, students. All are equivalent fractions. Why do the equivalent fractions represent the same part of the whole? How can we obtain one from the other? So if you see, all these are the equivalent fractions, and the all equivalent fractions are representing the same part of the whole. Okay, students. So how can we obtain one from another? So if it is there 1 by 2, that is equals to 2 by 4, which means what, students? We can also write the 2 by 4 in another form. How it is? That is 1 into 2 divided by 2 into 2. 1 into 2, 2 into 2. We can also use the 2 by 4. If you carefully observe here, we have written 2 by 4 in this form, and in the numerator and both the denominator 2 is common, 2 is same. So if you just neglect it, the remaining fraction is the fraction which is the older fraction. So whenever you are multiplying both numerator and denominator with the same number, the fraction value, then it will give rise the equivalent fractions. So if you are having 1 by 2 and if you multiply numerator with 2, denominator with 2, it will give rise 2 by 4. It is the equivalent fraction. And if you are having 1 by 2 and if you are multiplying numerator and denominator with the same number, then it will give rise 3 by 2, 6. It is also an equivalent fraction. So if you are having the same number and you are again multiplying it with say some same number numerator and denominator, it will give 4 by 8. It is also equivalent fraction. That is the relation between equivalent fractions, students. To find an equivalent fraction of a given number, you may multiply both the numerator and the denominator of the given fraction by same number. That is the case, students. So 1 by 3 into 2 by 2 equal to 2 by 6, 1 by 3 into 3 by 3, 1 by 3 into 4 by 4, like that. So here is an activity you can do, students. So try these, students. So you have to write the equivalent fractions for the 2 by 3, 1 by 5, all those things. So is there any other way to obtain equivalent fractions, students? Is there any other way? So if you see here, out of the 6 trees or triangles, 4 is shaded. Here if you see, this is one box, this is one box, this is one box. So out of the 3, we have shaded 2 things. So basically the picture represents the same, but because of this separation boxes, that 4 by 6 and here is 2 by 3, students. So here it is the 4 by 6 and that is equals to this, here it is the 2 by 3. So students, if you divide the 4 by 2, 4 by 2 and 6 by 2, 4 by 2 is 2, 6 by 2 is 3. So what happening here? You are dividing with the same number on both numerator and denominator. So previously you have multiplied on both the numerator and denominator with the same number. Here you are dividing with the same number both the numerator and denominator, students. So to find an equivalent fraction, we may divide both the numerator and the denominator by the same number, students. Okay, that is the case. To find an equivalent fraction, we may divide both the numerator and the denominator by the same number. So one equivalent fraction of 12 by 5 is what? So 12 by 5. So you have to write the equivalent fraction for it. How you will do it? So that is, we have to divide both the numerator and denominator with the same number. So you will divide it with 3. You will get 4 by 4. So 4 by 4 and 4 by 5 and 12 by 15 are equivalent fractions. So there is an example, students. Find the equivalent fraction of 2 by 4 with numerator 6. So we have to find the equivalent fraction and condition is it must have the numerator 6. So students, that is the example 3. So there is 2 by 5 and we have to find the equivalent fraction. So that fraction numerator is given, that is 6, and whatever the denominator. So numerator is fixed, students. So here it is the fraction. So if you want to get the equivalent factor, how you will do it? Whether you will multiply with the same number both numerator and denominator, or you will divide with the both numerator and denominator the same number. Suppose here there is 2 and you have to get the equivalent fraction whose numerator is 6. So how 2 is transformed into 6? If you multiply it with 3, then the 2 is transformed into 6. So one thing is, what you do to the numerator, you have to do the same thing to the denominator. So again 3 2s are 6 and 5 3s are 15. So 6 by 15 is the equivalent factor, like that. So if you see here, there is an example 15 by 35. We have to get the equivalent factor with the denominator. So the denominator must be 7, students, whatever the numerator. So if you want the equivalent factor, whether you have to multiply it or whether you have to divide it with the same number. Here 35, it must be converted into 7. How you will get 7. So whenever you are dividing this 35 by 5, you will get 7. So what you do to the denominator, you have to do with numerator. So 15 by 5 is 3. 3 by 7. That is the case. Okay students, that is the case. Find the equivalent fraction of 2 by 9 with denominator 63. You have to do this task students. Next thing is simplest form of a fraction. So if there is a fraction, how to get the equivalent fraction that is having the simplest form. So if you see 2 by 5 and 6 by 15 are equivalent fractions, but which is the simplest form? 2 by 5 is the simplest form. So simplest form will helps to you do calculations easily. Okay students, let us try simplest form of a fraction. So here there is 36 by 36 divided by 54 students. So if you want to get the numerator, whether you have to multiply it or whether you have to divide it. So why we want simplest form, that's why we will divide it. So if you observe, for this you have to write the factors of it, same factors. Okay students, factors means numerator and denominator must have the common factors, that is except 1. Okay students, so if you divide with 2 and if you divide with 2 is a common factor to both, it will give rise to 18 by 27. So here also it is having the common factor of 1, and in addition to there also it is also having another factor. Suppose if 9 is a common factor, divide with both things with 9, it will get 2, it will get with 3. So if you see, there is no another common factor for both numerator and denominator except 1. So this is there are no 2 and 3 have no common factors, factor except 1. So 2 by 3 is in the simplest form students. So a fraction is said to be in the simplest or the lowest form if its numerator and the denominator have no common factor except 1. Now students, that is the case. If you want to do it in the shortest way, you have to find the HCF of the numerator and the denominator and divide the HCF of both. That is the another case students. That's it. So there is the example exercise problems we have to do students. If you have any doubts, please feel to comment below. If you have the exercise videos want to be uploaded by us, please comment below. Like fractions. Then we will turn into the like fractions. What are like fractions? We have seen what are the equivalent fractions. Here we are going to see what are like fractions. Fractions with the same denominator are like fractions. Fractions with same denominator. Fractions with same denominator are called as the like fractions students. Okay, so if you see here examples 1 by 15, 3 by 15, 9 by 15, 6 or 8 by 15. So all these fractions are like fractions. Why means because the denominator is same for all the fractions. That is the main reason. Then what about the unlike fractions students? It is very simple. If the denominators are different, unlike fractions. So if denominators are different, then we say those as unlike fractions. This is the case students. Okay, So take 7 by 27 and 7 by 28. These are what? Unlike fractions. Why? Their denominators are different. Even though numerators are same, we don't say them as the like fraction, students. So one thing is denominator must be same, then only they are like fractions. If denominator is different, they are unlike fractions. That is the case, students. Next thing is comparing fractions. Comparing fractions. How to compare the fractions? No, learned about like fractions, unlike fractions, equivalent fractions, proper fractions, improper fractions, mixed fractions. So lot of information you have gained, students. So here how to compare the fractions. So Sohni has 3 1/2 rotis in her plate and Rita has 2 3/4 roti in her plate. So simply talking, who is having more rotis? So if simply we can say Sohni having more rotis. Why? If you see Sohni, she is having 3 full rotis and half roti. If you see Rita, she is having 2 full rotis. So 2 is smaller than 3. That's why Rita has lesser roti, students. Okay, that is the thing. So again here if you consider 1/2 and 1/3, can you tell now which is greater? So if you seeing simply 3 and 2, we can easily guess, but by seeing 1/2 and 1/3, which is greater? How to compare them? So let's goes to the basic understanding. 1/2 means there is a full, and out of this full we have make it into 2 parts, 2 equal parts, and we have taken 1 part. So this is the 1/2. And what happens to 1/3? The same full is making into 3 equal parts, and one out of it is shaded. So it is 1/2 and it is 1/3. So seeing these both things, which is greater? Obviously we can say this is greater. So 1/2 is greater than 1/3. Okay, students, that is the case. Why? Because here in both cases we are taking one part only, one portion only, but the size of the portion is small in 1/3, students, and it is big in 1/2. That's why 1/2 is greater. If you take 1/4, it is much lesser. It is much lesser. That 1/3 is greater than 1/4. Like that, students. Okay, students. Now, if I ask you which is greater, 1/4 or 3/10, how you tell? So it is somewhat difficult, students. So if you plan to write diagrams like this pictorially, so it is a lengthy process. So we can't guess them. Okay, students. So in this case, how to solve this problem? How to tell which is greater? So students, we need a systematic procedure to compare fractions. Let's know about it. So comparing fractions. So if they are like fractions, so the fractions which you have to be compared are like fractions. In that case, how we will do it? So simply suppose in the case of like fractions, what happens? Denominator is in like fractions, denominator is same. That's why in this case, greater the numerator, greater is the fraction. Greater the numerator, greater the fraction. Greater the numerator, greater the fraction, students. Okay, that is the case. I will give you example. You have to compare 1/2 13 and 11 by 13. So which is greater? So if you observe carefully, denominator is same. So these are like fractions. So whenever in the case of like fractions, whenever the denominator is same, just you have to look for numerator. So in the numerator, which number is greater? So here it is 1 and here it is 11. So 11 is greater than 1. So this fraction is the bigger fraction. So simply you can say 11 by 13 is greater than 1 by 13. That is a simple task. Okay students, that is the case. That is the case in the case of like fractions. Here there is 3 by 8 and 5 by 8. Which is greater than? They are like fractions. 8 and 8 are same. So that's why just look at the numerator. And 3 and 5, which is greater? That 5 is greater. Which is greater students? 5 is greater. That's why 5 by 8 is greater than 3 by 8 students. Like that. Here there is 3 by 4 and 4 by 4. Like fractions, denominator is same. Numerator is 4 is greater than, so 4 by 5 is greater than 3 by 5. That is the thing students. 11 by 20 and 13 by 20. In this case, how to deal the task? It is also so simple students. What we have to do is which is greater? 13 by 20, 11 by 20 and 13 by 20. So in this case also, what we have to do is simply do the task, that is 13 by 20 is greater than y, 13 is greater than. Okay students, like that you have to do. Suppose if you are having unlike fractions, how to do the task? So here there is 1 by 3 and 1 by 4. How you will compare it? Here there is 2 by 3 and 3 by 5. How you will compare those things? Which is greater? Which is smaller? So which are having more, which is the greater fraction? Suppose if you are having the unlike fractions with same numerator, they are the unlike fractions. That's why denominator is not same. But if the unlike fractions are having same numerator, how you will do this task students? So here there is 1 by 3 and 1 by 4. Numerator is same, denominator is different students. So which is greater than? If you see pictorially, you can easily say 1 by 3 is greater than students. So for that, in 1 by 3 students, we divide the whole into 3 equal parts and take one part and its length is increased high. In 1 by 5, we divide the whole into 5 parts and we have taken one part. So that is the case students. Simply you can say that 1 by 3 is greater than 1 by 5, which means the length or the size of the 1 by 3 part is greater than 1 by 5. So pictorially if you do it, you can know students. But if you want to know how we can do it, so again there is an example. Suppose if 2 by 3 and 2 by 4, which is greater than? 2 by 3 and 2 by 4. Numerator is same, and so if you say, I pictorially if you represent the same situation, that 2 by 3 parts length is bigger. That's why again that is greater than students. And in this situation also students, if you say there are no common, the common numerator is 2 students, not 1. Here it is the common numerator is 1, but here it is the common numerator is 1. So students, how you will do it? So there is the formula. If the numerator is same in two fractions, the fractions with the smaller denominator is the greater of the two. So what is the thing you have to remember is, if numerator is in unlike fractions with same numerator, how you do it? So smaller denominator is greater fraction. If denominator is smaller, the fraction value is greater. Smaller denominator is greater. Smaller denominator is greater. Smaller denominator is greater fraction. 1 by 8. same numerator. So if you do the see the denominator, which is smaller is fraction value is greater, like this, students. Suppose if you want to compare 2 by 3 and 3 by 4, if you see here, there is no common numerator, there is no common denominator. So how to do this task? So the numerator and denominator both are different, students. How you will do it? So 2 by 3, 3 by 4, how you will do it? So in this case, students, in this case, how you will do it, the students? We will find the equivalent fractions, students, so that we will find for the equivalent like fractions. So we will write the equivalent fractions for these things, students. So if numerator and denominator are different, how to do this task? How you will compare which fraction is greater or which fraction is smaller, students? So for this task, students, what we have to do is we have to write the equivalent fractions for each fraction, and we have to search for whether there is any like fractions for both. Suppose if you write the equivalent fractions for this, student, and also for this, you will get 4 by 6, 6 by 9, 8 by 12, 10 by 15, like that. So you can also write equivalent fractions for this also, that is 6 by 8, 9 by 12, 12 by 6, like that. So in doing equivalent fractors, writing equivalent fractions, we have to search for is there any like fractions in the equivalent fractions. So if you see here, there is a 8 by 12, here there is 9 by 12. So both these are having same denominator. So both these fractions are like fractions. So as they are equivalent to these fractions, so 8 by 12 and 9 by 12, which is greater? We know that 9 by 2 is greater. So that's why, as they are the equivalent fractions of these fractions, which is greater than 3 by 4 is greater than 2 by 3. Like that you have to find out for equivalent factor, students. Compare 4 by 5 and 5 by 6. How you will do this task, students? Example 6, 4 by 5 and 5 by 6. The fractions are unlike fractions here. Numerator and denominator is different. So what we have to do? We have to write equivalent fractions for 4 by 5, 8 by 10, 12 by 15, 12 by 15 or 16 by 20, 20 by 25. All these are the equivalent fractions. For this, if you write the 10 by 12, 15 by 18, 20 by 24, 25 by 30, like that. Is there any denominator same? No denominator. So we have to continue this process. Again 24 by 30, 38 by 35, like that. So if you consider do this here 30 by 36. So just stop, students. Here there is denominator 30, here also there is denominator 30. So these fractions are like fractions. So 24 by 30 and 25 by 30, which is greater? Obviously 25 is the greater. So obviously 4 by 5 is less than the 5 by 6, which is greater. So like that you have to do the task, students. So what is the simpler way to do this task, students? So if you have 5 by 6, you have 13 by 15. So every time writing the equivalent fractions and comparing is somewhat difficult. So what you can do is so we should first get their equivalent fractions with the denominator, which is a common multiple of 6 and 15. So here there is denominator 6 and here denominator is 15. So you have to look for a common multiple for 6 and 15, students. So you have to look for the common multiple for both denominators. Okay, students. So what is the common multiple, students? Here if you do, the common multiple is 30. 30, students. How you will get? 6 5 is 30 and 15 2s is also 30. Common multiple. So you have to multiply, you have to make this into common multiple, like that 5 by 6 into we have to make this into 30. That's why 5. Whatever you multiply with the denominator, you have to do the task with the numerator. So it will becomes 13 by 15 into numerator and denominator both with 2. So it will becomes 5 5s are 25 by 30, and here 13 2s are 36 by 30. So which is greater? And obviously denominator is same. So numerator which is greater, 26 is greater. So it is the greater thing. Like that, students. Next thing is that addition and subtraction of fractions. So we know how to compare them. Then how to add, subtract, students. Addition and subtraction of fractions. Addition of fractions. So we have already do addition and subtraction for integers, natural numbers, whole numbers, like that, students. Okay, there are some properties also. So we'll do like this also. So here we know. So if you want to adding and subtracting like fractions, students, first we will do it for like fractions. Like fraction means denominator is same. Denominator is same. Okay, students. For that, first if you do it geometrically, if you have a grid, it is having 7 rows and 4 columns, like that. How many total boxes are there? 28 boxes are there. So here the 5 are here 5 are shaded, so 5 by 28. Here so here 5 are shaded, 5 by 20. Here 4 are shaded, 4 by 28. So totally how much are shaded? So here 5, here 4, that is 9 by 28. So if you just plus put cell symbol here, you will get 5 plus 4 equal 9 by 28, like that. So how we have done it? So in the same situation is, look at this example also. Here 2 are shaded, here 3 are shaded. It is the what? It is 1 by 4 plus 1 by 4, 2 by 4. If you see it, here it is 1 by 3. Or so if you take this example, students, 1 by 4 plus 1 by 4, 2 out of 4 things. So that is 2 by 1 plus 1 by 4, 2 by 4. That is nothing but 1 by 2. Here there are 4 parts. How much parts are shaded? 2 parts are shaded. So you can write it as 2 by 4. Okay, students. Also there are 4 parts. No, out of 4 parts, 2 parts are shaded. So 1 part, 2 part. If you add also, you will get 2 by 4. So what you can understand from these things? Denominator is same. Then you can simply have to add a numerator. This is also the same example. So what is the steps you have to follow? First thing is, whenever the like fractions, which means whenever the denominator is same, just add the numerators. That is the case. And write the result of step 1 and step 2. Okay, students, that is the case. Just add the numerators, denominator is same. Write it as thing. So how to find the balance, which means how to subtract 2 fractions. Okay, students, if there is 5 by 6 and if there is 2 by 6, how to subtract the like fractions? It is also so simple, students. First thing is you have to subtract the numerators, that is 5 minus 2, and write the denominator same. So that is the thing. Result of that is 3 by 6. That is called 1 by 2. So procedure is that, students, first you have to add the numerators, and second thing is you have to write the same denominator. Don't to add or not to subtract. Third thing is write the step 1 in numerator, step 2 in denominator. For subtraction also the same procedure. Subtract the smaller numerator from the bigger numerator. That is the thing. Next thing is common denominator, like that. Adding and subtracting fractions. Okay, students, if they are like fractions, we can do it simply. Suppose if they are not like fractions, how we will do unlike fractions? Okay, students, sometimes it is difficult. Suppose if you have to add 1 by 5 and 1 by 2, how we will do this task, students? So for that, students, we have to make them into like fractions. Then only we can do the task. For that we have to look for common multiple. So what is the common multiple for 5 and 2? That is 10. So you will multiply 1 by 5 with 2 and 2, and you will multiply 1 by 2 with 5 by 5, so that it will becomes 2 by 5 to the 10, it will becomes 5 by 5 to the 10. Then there becomes like fractions. If you want to add them, simply first thing you add numerators, that is 2 plus 5, write the denominator. Next thing is 7 by 10. That is the procedure. So finally 1 by 5 plus 1 by 2 is equals to 7 by 10. Okay students, if you add, or if you want to subtract, procedure is same. So what are the fractions? Resulting factors are 2 by 10 and 5 by 10. 2 by 10, 5 by 10. You have to subtract. For that, first you have to write the bigger term, next lower term, smaller term, denominator. That is 3 by 10. That is, you have to write the least common multiple, students. That is the case here. Subtract 3 by 4 from 5 by 6. You have to subtract 3 by 4 from 5 by 6. 5 by 6 minus 3 by 4. How you will do it? Simply first you have to write the common multiples, LCM, students. So 5 into 2 divided by 6 into 2. Why? Because 12 is the common multiple. Minus 3 into 2, how much? 3 into 3 divided by 4 into 3. Why? Because 6 2s are, and it is 12. It is also 12 for the process of 12, students. So denominator is same, like fractions, just write denominator and subtract them. You will get 1 by 12. It is the answer. So in this process we have to do, students. Here there are examples. So I will explain you this. We have to do this. Example 9. So we have to add 2 by 5 plus 1 by 3. How you will do it? So first you have to find out the LCM for denominators. LCM of 5 and 3 is what? Nothing but 15. Okay students, so just you have to make the both fractions into 15, students, like that. So 2 by 5 plus 1 by 3. So it becomes what? You have to multiply both the things so that you will get the least common multiple. That is 2 into 3 by 5 into 3 plus 1 into 5 by 3 into 5. So that is 3 to the 6 by 15 plus 5 ones are 5 by 15. So that is simply 11 by 15. In this way, how to do this, students? Suppose if they are given mixed fractions, how you will do this task? How you will do this task, students? So there is a problem. We are going to discuss about it. Example 11. So 2 4 by 5 and 3 5 by 6. First thing is 2 4 by 5 means 2 plus 4 by 5, and you have to add, no, 3 5 by 6 is 3 plus 5 by 6. First thing is add the integers, which means normally natural numbers, whole parts. So 2 plus 3 becomes 5 plus 4 by 5 plus 5 by 6. Now these two are the fractions. 5 plus, how to add two fractions if they are unlike? Just make them common multiple, find the common multiple, least common LCM, like that. So that is 4 into 6 divided by 5 into 6 plus 5 into 5 divided by 6 into 5. So if you do this task, they will become 6 4 is 24 by 30 plus 5 5 is 25 by 30. Whenever the denominators are same, like fractions, simply add numerators. That is 24 plus 25, that will become 49 by 30. So next thing is, students, 49 by 30, like that. 5 plus 49 by 30, students. There is a 5, no, 4 by 5 we have written this, and you are getting this answer 1 plus 19 by 30. Okay students, like that. So students, we can write this 5 plus 49 by 13, we can write it as 1 plus 19 by 30. 30 plus 19, 49 by 30. So if you do like that, it is 6 plus 19 by 30. That is nothing but 6 into 19 by 30. This is the way. Okay students, finally this plus this gives us this. So we have to separate these two things, students. I will do this, we have to do this. it is sharing, students. Okay, 12. So we have to find 4 into 2 by 5 minus 2 into 1 by 5. First you have to 4 into 2 by 5 means 4 plus 2 by 4, students, and minus of what we have to do, 2 into 1 by 5 is 2 plus 1 by 5. First thing is we have to subtract this from this. So first take out the whole numbers, that is 4 minus 2 plus 2 by 5 minus 1 by 5. You can simply do this, that is 2 plus 2 by 5 minus 1 by 5. So if you see, students, 2 plus, these are the like fractions, procedure is simple, that is 1 by 5, that is 2 1 by 5. That's it, students. In this way you have to do, students. So finally our chapter is completed. If you have any doubt, students, please feel free to comment below. So don't forget to subscribe Sreenath CBSE YouTube channel, students. Okay, so our chapter is completed. Let's go for the summary session. We will see what are the concepts in it. We'll just revise what we have learnt. So fractions, it is our present chapter, students. We have to learn how to just make a revision of it. So fraction, students, what fraction means. So fraction is nothing but a part of a whole, and part of a whole, students. So a fraction means a part of a whole group or whole region. So in the fraction there is numerator and the denominator. And coming to the fraction on a number line, how to represent the fraction on a number line. So if you have to make the parts of the space between 0 and 1 or inline numbers like that. So after doing it, proper fractions. What are proper fractions? Proper fractions always lie between 0 and 1, students. That is the one case. And next thing is that in proper fractions, numerator is always less than the denominator, students. Okay, and proper fraction shows the number of parts and shows the parts of a whole, part of a whole. These are about proper fractions. What about improper fractions? Suppose what are improper fractions is that, students, if the numerator is bigger than the denominator, we call them as the improper fractions. Then what is the mixed fractions? Mixed fractions are looks like a mixed fraction is a combination of a whole and a part. Combination of a whole and a part, like that, students. Okay, that is the case. So next thing is what? Equivalent fractions. So what are equivalent fractions? So those fractions are called equivalent fractions. Equivalent fractions values is equal, students, but their numerator and denominator looks like different, students. Okay, how you will get the equivalent fractions? So if you want to get the equivalent fractions, whether you have to multiply both the numerator and the denominator with the same multiple, or you have to divide with the same thing, then you will get the equivalent fractions, friends. Next thing is what? That is simplest form of a fraction. How you will get the simplest form of a fraction? So you have a simplest form of a fraction is that, students, for the numerator and the denominator there are no common factors except one, students. That is the simplest form. And next thing is like fractions. So if the denominator of both fractions are same, then we call as the like fractions. If the denominators of both fractions are not like, we call as unlike fractors. That is the thing, students. Comparing fractions. How to compare two fractions? So first comparing like fractions. If take the like fractions, the fraction which numerator is greater, whose numerator is greater is the greater fraction, students. Comparing unlike fractions. If you are having unlike fractions, we can't compare them. So what is the procedure you have to follow is, if the unlike fractions are having same numerator, in those tasks the denominator of which fraction is smaller is the greater fraction, students. So that's why if the numerator is small in two fractions, so 1 by 8 and 1 by 10, here 8 is smaller than 10, so that's why 1 by 8 is greater. So next thing is about addition. How to add? If there are like fractions, students, simply what is the procedure you have to follow is add the numerator, that's it, and keep the denominator same. And subtraction is also same. Subtract the numerator, keep the denominator same. And if they are unlike fractions, what you have to do? So you have to make them into like fractions, then only you can add them or subtract them. How to make like unlike factors into like fractions, we have already discussed like that, students. So finally our chapter is completed, students. Our summary is also completed. We have discussed all the chapter and all the summary, students. So hope you have understood well, students. If you have any doubts, please feel to comment below. Have a nice day, keep smiling. Bye bye, students.